So we are going to classify three-dimensional figures according to their properties, and we'll use nets and cross sections to analyze three-dimensional figures. We're going to use cross sections tomorrow. We're going to do half of this, and then we're going to play around with some nets. Three-dimensional figures or solids can be made up of flat or curved surfaces. Each flat surface is called a face, which is kind of weird seeing as that our faces are not flat, but it is what it is. Oh my gosh. An edge, I just forgot what the word was. An edge is the segment that is the intersection of two faces. So back in Unit 1, when we would talk about the intersection of two planes, I made a big stink about how two planes, because they went on forever, had to intersect in a line. Okay? These faces are part of a plane, but it's not the entire plane. So when a face intersects with another face, it just makes a segment of a line and not the whole line. You guys see the difference? So plane intersecting with a plane, we get a line that goes forever. Face intersecting with a face, we just get an edge, which is a segment. Cool?
Yeah.
Okay, perfect. And a vertex is the point of the intersection of three or more faces. It kind of looks like faces intersect at edges, and then the edges intersect at the vertex. Okay. Okay. So we're going to jump around a little bit. These are, you can see that we have a prism here. A prism is characterized by having the same shape on both of the bases, like the bases match. Not only that, but those bases have to be parallel to each other. Parallel, what? We're going to do half. Okay, parallel congruent bases that are faces. And then also the lateral faces are also parallelograms. Okay, a cylinder, we have two circular bases that are congruent. Hey, can you put your phone away? And then we have a curved surface that connects the bases. Okay, so think of like if you had a can of soup. You guys still have cans of soup at home? Okay, if you peel off the label, what shape is that label? It's a rectangle that gets wrapped around a cylinder, right? So the lateral side of a cylinder is just a big old rectangle. Sound good?
Yeah.
Okay. All right. Now, a pyramid is formed by a polygonal base and then triangular faces that meet at a common vertex. So the difference between a prism and a pyramid is that a pyramid ends in a point and a prism has two bases. You see one base and a point as opposed to two bases? Okay. A cone is formed by a circular base, and it has a curved surface that connects the base to one vertex. Now, look at these two. They're very similar, except this one has two bases, and this one has one and a vertex. Okay. Questions so far? All right. That's it for this page, right?
Yep.
Okay.
Oh, I finished my review.
Okay. Can we do it during your time? Okay, a cube is a special prism with 6 square faces. Okay, so all of the sides are squares. Other prisms and pyramids are named for the shape of their bases. So you can see all of the prisms have base, 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 right?
Yeah.
And they're named by the shape of the base. So this is a triangular prism because the base is a triangle. This is a rectangular prism because the bases are rectangles. This is a pentagonal prism because the bases are pentagons. Cool, cool? Okay. Across the bottom, we have pyramids. These are also named by the shape of the base. So this is a triangular base pyramid because the base is a triangle. Rectangular pyramid has a base that's a rectangle. Okay, everybody happy with this? Okay. So we're going to classify this figure. We're going to name all of its vertices, edges, and bases. Geez Louise. All right, what do you think? We don't have any information about whether these sides are congruent. So it's possibly a cube, but the safest thing to say would be that this is a rectangular prism. Okay, so we're going to call this a rectangular prism. And I know that it's a rectangular prism because it's got two bases and they're both rectangles. Okay, so the vertices those are where our edges intersect. So those are the points. Okay, so we just have to list all the points. And rather than saying point A, point B, point C, we're just going to say points A, B, C, D, so we don't have to write point a million times, but we do have to say that they are points. Points A, B, C, D, E, F, G, I didn't know this was going to be an alphabet test, H. Did I get them all? Okay. Edges. Okay, this is going to be exciting. We've got to get them all, so be ready to make quite a list. So the edges, these are our segments. These are the segments where our faces intersect. Okay, so let's start with AB, BC, CD, and DA. A, B. Because they're segments, they get the little segment bar above them. B, C, C, D, D, A. Okay, that takes care of the ones on the top. Let's go around the bottom, and then we'll do the up and down vertical ones. Cool? Let's have a system. So EF, FG, so on. E, F, F, G, G, H, and HE. Oops. I know, this part's a little bit tedious. Okay, 4 more. Okay, so now we want the vertical ones. Let's just go, it doesn't really matter, but let's go top to bottom. So AE, BF, CG, and DH. That's it. Okay, now we have 2 bases, which is really a matter of perspective, but I'm going to just say it's the top and the bottom. I'm going to use a different color. Okay, so instead of having to write out rectangle, I looked in the book, and the book just draws a little picture of a rectangle. Just make sure that I can tell your rectangle is a rectangle and not like a squished little parallelogram. You know, make sure I can tell that it's got right angles in it. So rectangle A, B, C, D. That's the top base. And then the bottom one is rectangle E, F, G, H. Okay, That's fun. A what? It said to do the bases, and it didn't tell us that we had to do all the faces. So we just had to do 2 bases. So I picked this to be the base and this to be the base. Because I said it was a rectangular prism. I don't know that it's a cube. Yeah.
So are all bases faces, but not all faces?
Correct. Yes, that is correct.
What's the square and rectangle one?
What do you mean?
Like all rectangles are square?
Okay. So to name this figure, we have to look at its base. So I see 1, 2, 3, 4, 5. So it's a pentagonal something. Is it a pyramid or a prism?
Prism.
Whoa!
It's hexagon.
What?
No, it's not. Rectangular pyramid.
1, 2, 3, 4, 5. I'm saying 5 sides for the base, and it ends at a point, so it's a pyramid like the pyramids in Egypt. Okay? So pentagonal pyramid. I wanted to say prism so bad. No. Pentagonal pyramid. Okay. So let's start with the vertices. Remember that these are the points, the points where our edges intersect. So they are points. A, B, C, D, E, F, E, and F. Okay. A, B, C, D, E, and F. Okay, edges. Okay, this is going to be a long list. Brace yourself.
I really don't.
Okay. All right, do you want to start by going around the base, or do you want to start with the ones that end in the point? Okay, so AB with the little segment, BC, CD, DE, and EA. It's long, but it's not as long as the last one. Okay, now we want the ones that are slanted, that end in the point F. So AF, BF, CF, and so on. AF, BF, CF, DF, and EF. Whoever did this obviously hated children.
Whoever did this has serious mental issues, and I think they need therapy.
I think we're all going to need a little bit of therapy after this one. All right, what about the bases? How many bases do we have? 1. Okay, thank God. Okay, so our bases, we just have 1, and it's this guy. So that is pentagon. Let's write it out, and then I will look into that for us. Pentagon, A, B, C, D, E. Yep. Not F, because F is in a different plane. Remember when we named planes, we just needed 3 coplanar points that were non-collinear? To name a shape, we need the vertices for that shape. Cool? Okie dokie. All right, what have we got here? Yeah, we have a cute little cone. Okay, we have vertices. It just has one point N. We're gonna come back to the edges and bases because I don't remember how to name the edges. I don't know if we say that there are any edges. I know how to name this base. Okay, it has a base that is a circle.
Oh my gosh, we're missing the edges. Perfect.
Guys, I think that we need the center of the circle in order to name it. All right, we're gonna come back to this one. Sorry, I'm having a brain fart. What? I was thinking we could call it N, but that's not in the base. So I think we need the name of this point in order to name it. So we might have to make up a name, but we're gonna come back to it, okay? All right. Classify the figure.
No.
What? Oh, do you have to go now?
I didn't know we were starting.
All right, what kind of figure is this? So we look at the base. It's a triangle, so it's going to be a triangular something.
Prism.
Yes, triangular prism. Okay. Do we need to finish this one?
No.
Okay. We're not going to finish this one because I can tell that we're ready to be done.
Well, are we done with everything?
No, we're going to talk about some nets. Okay, so a net. Oh my goodness. N-E-T, like a net.
Volleyball net.
Like a volleyball net. A net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. We're going to identify a three-dimensional figure from a net by looking at the number of faces and the shape of each face. Okay. Some strategies. We're going to look for one or two faces that are different from the rest, and those are going to be our bases. Does that make sense? Okay. All right, so if I'm looking at this one, do you see that this side, this side, this side, and this side are going to have to fold up? Okay, so automatically I know that this is my base and that this is another base. Does that make sense to everybody? Okay. What do you notice about all of my faces? Yeah, they're all the same. So which is our solid that has 6 congruent faces? It's a special type of rectangular prism. What are you guys doing? Why? Stop. Okay, it's a cube. This is a cube. Cube has 6 congruent faces. Okay, the next one is super weird. It's only got one base, which is a circle. It's a cone. Yeah. If I wrap this around the base and then this part and this part come together, it'll make a little point right there.
Yep.
Okay. This is a cone. It's making me want ice cream. Okay, now, this also has a base that is a circle, but it's got 2 of them.
Cylinder.
Yeah. How many L's in cylinder, guys? I don't know. It's hard to tell. Is it just one? All right, what about this one?
Yeah, it's only one.
Okay, one base.
Cylinder.
Cinderella, what? Okay, so I've got my base. I fold up my sides. Do they make another? Do they go to another base or to a point? A point. So is it a prism or a pyramid?
Triangular pyramid.
Triangular pyramid. Good. Okay. Okay. This is cross section, so we're gonna be done. Okay, and we're back. Okay. So we skipped over the cone because I couldn't remember what to do. So what we're gonna have to do is draw in the center of the base, which is this circle. This circle right here is the base, and we'll call the center of it M. That way we can name the base, and that way we can name the cone. So we call this we can name the base circle M. Oh, good grief. Sorry. How many computers being done? Circle M. Okay, and as for the edges, we don't have any, which is what I thought, but I wasn't positive. Edges, we have none. Okay, where's these edges? Okay. Cool. All right, now I'm going to finish, which one was it? I'm going to finish this one that the kids were tired of. Okay, so we've got vertices. Oh, geez. What's the first letter? T, U, V. Okay, we're going to start with T. Okay, remember that these are points. T, U, V, W, X, Y. Do we have Z? No. Okay, the edges. Are TU, UV, VT. Okay, that's the top base. Now I'm going to go to the bottom base. WX, XY, YW, and now we'll do the vertical edges. So T, W, UX, and VY. And the bases. Jeez. Okay, so the bases are triangles. So that is triangle TUV and triangle WXY. Okay, now we're done.